Elizabeth Grossman is a freelance writer and journalist specializing in environmental and science issues. She's the author of Chasing Molecules, Poisonous Products, Human Health, and the Promise of Green Chemistry. And prior to this new book, she wrote High-Tech Trash, Digital Devices, Hidden Toxics, and Human Health. Her work has appeared in the Washington Post, Salon, Huffington Post, The Nation, Mother Jones, and Grist. Elizabeth actually traveled to places like the Arctic archipelago and lived aboard a ship with a bunch of scientists who monitored and measured pollutants. Welcome to the show, Lizzie.
Thanks so much.
Great. So what got you interested in writing about environmental toxins and green chemistry?
Well, it actually began with very local water quality issues where I live here in Portland, Oregon, and I live actually on the banks of the Willamette River. And a few years ago, I was doing some research into water quality in the Willamette, trying to get a sense of how the ongoing progress towards keeping that river a whole lot cleaner than it used to be was holding up. And I discovered to my amazement that back around 2000, 2002, the majority of the pollution going directly into the Willamette from industry was coming from high-tech and related industries.
Wow.
So that set me off on this big journey of finding out what that was all about.
Mm-hmm. Now, these chemicals that are being dumped in our rivers and streams, and, you interview a scientist in your book named Dr. John Warner who said, quote, I've synthesized over 2,500 compounds and I've never been taught what makes a chemical toxic. I also have no idea what makes a chemical an environmental hazard. That's so shocking that scientists are not taught about toxicity in school. Can you talk a little bit about that?
Yes, that was one of the most extraordinary things that I learned in the course of writing this book, that when I started out investigating what these chemicals were, why we were using them, and then started discovering that they were not just coming out of smokestacks and drain pipes and big industrial sources, but many of these same chemicals are used in everyday products, and they seem to be coming out of them as well. So I wanted to know, how on earth is this happening? Why have we decided to use these materials in the first place? And when I started talking to chemists, this kind of scientists who actually make these materials in molecules, people like John Warner, I learned that if you're getting a degree in chemistry and you're going to set off on a career making new chemical materials, you never have to take a course in ecology or toxicology or any kind of environmental health science that would even train you to look for these kind of impacts.
So amazing and so scary. Now, hopefully things are changing. Before we talk about the good news, let's just talk a little bit about the chemicals that we're being bombarded with in our daily lives. Can you tell us some of the everyday toxics we're exposed to in food, for example, to start with? And why don't you speak a little bit about the chemical DEP, for example?
Well, I'll just back up a little bit. The chemicals that I focused on in the book are chemicals that are used primarily in sort of everyday and household products, things that range from electronics to cookware to toys, all sorts of appliances, personal care products, and cosmetics. And it turns out the chemicals that make up these really, really useful things that make flame retardants, and they make waterproofing surfaces and nonstick surfaces, and they make detergents and hand lotions and shampoos and all sorts of really, really useful things. It turns out a lot of the chemicals that make those materials and those products, they don't actually stay put. And they can get out of the finished products, and they can find their way into air and water and household dust, and they can find their way into the food system. And so these chemicals are kind of with us all the time and are, in fact, getting into our bodies and our children's bodies just constantly. And the chemical that you asked me about is one that falls in a category of what are called plasticizers that are commonly used with PVC plastics, things we think of as vinyl. That stands for polyvinyl chloride. And they help make that material flexible. But it turns out that stuff that makes the plastic flexible and useful, and it's also used in cosmetics and personal care products and synthetic fragrances. It gets out of those products and is turning up in our bodies, where it can interfere with how hormones work, with some not very happy results for overall health systems.
Right. This DEP, I was surprised to read in your book, you say that it's found in like if you buy a box of cookies and there's a little cellophane, it looks like clear plastic window, that it's in there and it could actually migrate into the food. It seems like you think you're safe if you don't drink out of a plastic water bottle or you don't use Teflon or whatever, but here it is, this stuff is really pervasive.
Yeah, all of these chemicals are really pervasive, and one, sort of going back to the question you asked me about what I learned talking to John Warner, who's one of the founders of the field that's called green chemistry, was that one of the things that has happened because scientists who were making these materials have really not been trained to ask questions about how these materials would behave outside of the amazing shatterproof refillable water bottle or the amazing non-stick cookware or the raincoat that constantly sheds water, is they assumed that these materials would not interact with living cells, and so it would be safe to coat food wrappings with them or rub them on your skin or heat up food in them. But in fact, they actually do have chemical structures and behaviors that allow them to interact with living cells, and that's where the potential health problems start.
And these, just getting back to food for a second, the chemicals are in like pizza boxes and the linings of microwave popcorn, and all this stuff migrates. Where else can we find some of these chemicals that might be?
Yeah, there are lots of different chemicals, and the chemicals that you're talking about that are the kind of grease-proof surfaces, they're a similar kind of chemical that make non-stick surfaces that are used kind of generically. We think of them as Teflon, and they also make stain-resistant things. The chemical is a little different now, but what we used to think of as Scotch Guard, things that you spray or coat fabric with so it would resist stains. That's one set of chemicals. And in fact, there's been quite a lot of effort to try and begin to come up with alternatives to those chemicals, and the Environmental Protection Agency just before New Year's issued what it's calling chemical action plans that are aimed at trying to get some of these hazardous chemicals out of common use and come up with some safe alternatives. And yeah, there's so many of these chemicals. The non-stick coatings are one kind. Those plasticizers that I mentioned that go into PVC plastics that are what make them flexible and bendable. Again, people are working to try and come up with alternatives that will not have these adverse impacts.
If you're just joining us, I'm Beth Greer, and I'm speaking with Lizzie Grossman, author of Chasing Molecules, a book about poisonous products, green chemistry, and health.
Speaking of alternatives, I'm aware of the issue of PFOA and Teflon, and then they're now talking about this new green non-stick cookware scan pan. And in your book, you say it's really hard to tell what chemicals that they're using in that. I actually own a scan pan. I thought, I'm going to get rid of my Teflon, and this is like the best non-stick pan I've ever tried. And so, but you say that if it says PFO free and green on the label, that it might not be really as safe as we think.
Yeah, I mean, one of the really, really confounding things I learned is that even if a chemical manufacturer follows all the rules laid down by the EPA under the law that manages chemicals that are used commercially, one of the things a manufacturer can do is say that their chemical invention is a piece of proprietary and confidential business information, and they don't ever actually have to say what's in that product. And when I started seeing all of these advertisements and notices about these, eco-friendly, quote-unquote, green nonstick pans, I thought, wow, let me try to find out what's in them. And sometimes I'm an investigative journalist, but I sometimes feel like I'm a dog that won't let go of a sock that it's got in its mouth, and I just get really, really persistent. And I looked and looked and looked, and honestly, you can find out all the things that the manufacturers claim the pan will do for you in cooking, and all the things that the chemicals we'd like to avoid do, but I could not find out any real substantive list of what was going into those pans. And they might be perfectly safe, but on the other hand, we really don't know. The information's utterly incomplete.
Right, we don't know. And another thing we don't know about, which you write about so well in your book, is about nanotechnology and in the personal care products. I mean, they're found in the socks, and it's hard to find like a dishcloth, a kitchen dishcloth without nanoparticles in it, which bothers me. But it is found in our cosmetics and sunscreens. And can you talk a little bit about that?